Good Monday afternoon to you. This is the severe weather update for the Carolinas for Wednesday, March 5th. For places east of Winston-Salem to Charlotte to Columbia to Augusta, Georgia, places east of that line pretty much have a better shot of seeing some pretty intense thunderstorms compared to west of that line. So the yellow here indicates a slight risk of seeing some severe thunderstorms. This includes all hazards, damaging winds, perhaps some hail, and a risk for a tornado or two. In the darker green, you have the risk of seeing some isolated severe thunderstorms, and the lighter green is just general thunderstorm risk. But this is beginning from 7 a.m. Wednesday, March 5th through 7 a.m. Thursday, March 6th. So as for the timing, we will look at first the European model. This shows at roughly 4 a.m. a line of showers and thunderstorms approaching the mountains of North Carolina. As we push this forward, it looks like Asheville down to Greenville, Spartanburg will be affected by this line by probably just after 5 a.m. Charlotte getting in on the action around 7 a.m. and Raleigh just after lunch. And then this line and associated front eventually shifts off to the east and off the coast of the Carolinas by, I'd say, 1 a.m. Thursday morning. This is according to the ECMWF, but the timing in the NAM is pretty close to the ECMWF, and this is giving us a little bit more confidence in the timing of these potential thunderstorms. The NAM, the European model, as well as the GFS, all have the this prefrontal band of potentially showers and strong to severe thunderstorms approaching the Charlotte region by 7 a.m. and then points eastward like Raleigh and Florence, South Carolina just after lunchtime, and getting into the late afternoon and evening towards Wilmington, New Bern, and Elizabeth City, and then Hatteras after that, and then eventually off the coast. So all the models paint a very similar picture. So if we get down to the nitty-gritty details, here's the 12Z HER model. This is as far out as it goes, so I can't go any further than 7 a.m. Wednesday. This shows a little bit more detail as a pretty much a broken line of showers and thunderstorms across western parts of North Carolina, getting a little bit more solid across parts of the upstate of South Carolina here, just to the south and east of Greenville, Spartanburg, by 7 a.m. Wednesday morning. This is the latest HER. If we can go out any further, we would, but we can't. So we're going to look at the 3-kilometer NAM now for our area. So here is Charlotte. Right there, there's Raleigh, Durham, there's Columbia, and Asheville is somewhere over here. There they are. And Greenville, Spartanburg is right there. Atlanta getting in on the action by 1 a.m. Wednesday morning. If we push this forward a little bit, by 7 a.m., this particular model has the line of showers and potentially strong to severe thunderstorms approaching Charlotte by 7 a.m. just in time for the morning rush. So that's awesome. But some very strong winds are possible with this line. And given the environmental factors, which we'll look at in a moment, I wouldn't be surprised if you had some embedded rotation somewhere along this line here, pretty much from Statesville southward, has the potential, maybe even a little bit more north of Statesville, say just west, or I'm sorry, just east of Wilkesboro, and point southward. Wouldn't be surprised if she had some embedded rotation within these lines of thunderstorms. But this eventually pulls eastward through the day, and what is concerning with this is the potential for a more discrete storms to form out ahead of this main line here. And I'll show you why this is pretty concerning right now. Of course, this is just one model run from one model, so this isn't necessarily that like concrete, but it does paint a pretty good picture of what might occur. And of course, these things will change. And then on the back end of this, towards the evening, towards 4 p.m., you might have another round of showers and thunderstorms. The environment back here behind this may or may not be convectively, what's the word? I don't know either. I want to edit this part out.
I need to done.
Hold on, this is
I trying to say, oh man.
No, I'm not trying to say that.
Oh man. I trying to say, oh man. I need to done. Can you do that in the?
Oh, I know. Oh, shit. These storms back here towards Charlotte region, they may or may not be. Let's see. These storms back here towards the Charlotte region might be a. What?
I trying to say, oh
Convectively.
Man. Oh man, I need to done.
Recover. Yeah. Let's see. The atmosphere behind this main line may or may not recover from the intense convection from the morning. But this particular model run does suggest that some type of recovery is possible across the Western Carolinas. And these storms, given the environment behind this line, these will be more of a damaging wind threat than anything else across the Charlotte metro region, probably around 5 p.m. So just in time for the rush home. So, hopefully this is not going to be the case, because Charlotte looks like to be getting in on the thunderstorm activity, both the rush to work and the rush home from work. And here is the environment. This is what the environment looks like as those storms are approaching the Charlotte metro area on Wednesday morning. A couple things to note. Notice the very, very moist air mass by the difference between the red line, which is the temperature line, and the green line, which is the dew point. If those two lines are very, very close together, we have a very, very saturated atmosphere. You have 86% relative humidity all the way up to about 450 millibars, 76% at 300. You have 100% over here at 850 roughly. So, this atmosphere is not moisture starved, but what we are lacking is convective instability. Here at Cape, our convective available potential energy surface space is only 700 joules per kilogram, or 7, not even 700, not even 100. It's 7 joules per kilogram. That is not that great. Now, here's a special type of some sort of entrainment CAPE, where it's a special type of calculation. It estimates 318 joules per kilogram, but even that is lacking, as the surface-based stability, or the convective inhibition, is negative 54. So we're definitely going to need some forced type of convection. And this graph over here is called the hodograph. And this is pretty much a graph of the wind direction and how it changes with height, as well as speed here. So this is like an r theta. So if you know your polar coordinates from your math course, this is a r, which corresponds to the wind speed, and theta, which corresponds to the wind direction. You can graph that here, and as you go up along the graph, you're going up in height. So this is half of a kilometer. There's 1 kilometer up. There's 2 kilometers, 3, 4, and so on and so forth. And if you want to really get into severe weather forecasting, then one of the things that you want to look for is this low level curvature of the what we call the hodograph. This hodograph, when it exhibits some very sharp low level curvature here, this is indicative of strong low level shear, good enough for tornadoes. In fact, this is a very superb hodograph here as far as the low levels go. And you can see even the wind barbs here. We're up across more than 50, 60. There's 65 knots just above the ground there. So we have a very strong low level jet. And this is a very, kinematically speaking, this is a very good representation of what you would want as far as severe weather. Thermodynamically, it leaves something to be desired. Here's another look at this hodograph here. This is for Charlotte again, 7 a.m. And you can see why severe weather is going to be pretty much a concern across the Charlotte metro region. Now, once we get this line to push eastward, typically, once we get this line to push eastward, east of Raleigh-Durham, the environment becomes a little bit more unstable. Not too much, but a little bit more so. Notice that we still have the very good low-level curvature in the hodograph. This is a model profile from the coast, so just ahead of the line, so that we do not become convectively contaminated in this profile. But we only have 120 joules per kilogram of mixed layer CAPE. That's lacking there. This is at 1 p.m. Towards the coast. But low level shear is 43 knots. That is more than adequate for tornado formation. Deep layer shear 60 to 68 knots, depending upon if you're going 6 kilometers up or 8 kilometers up. Typically, supercells, we like at least 30 knots of shear. Deep layer shear, 0 to 6 kilometer deep layer shear. Here we have 60. So we have more than enough low level and deep layer shear for tornado formation, but we do not have the instability, the thermodynamics. Kinematically, this is almost a perfect case, but thermodynamically, it looks to be lacking just a bit, and that's because of you notice that this red line here, this temperature line, gets to the right of this blue line here. That is indicative of a cap, and it's very weak. But just above that cap, you got 7.3 kilometers or Celsius per kilometer lapse rate. So that is a pretty good lapse rate for this area for this time of year. But this is if we had more instability, this would have been a nightmare scenario, especially across the coastal plains of the Carolinas. But because we do not have any instability, that might be our saving grace for a more substantial severe weather outbreak. So to recap, mainly a damaging wind threat for the western parts of the Carolinas. getting into damaging winds, perhaps some hail and a tornado risk for the eastern parts of the Carolinas starting Wednesday. Of course, I will keep you updated with shorts and perhaps another video tomorrow evening to solidify the timing and the threats. So thank y'all for watching, and I will see you in the next one.